In the following demonstration, we're going to be using these four items that you're seeing in the picture. Here on the left is an ozone, O3, and ion generator, which we use as a control to show that the second device, the air ion counter, is operating properly. And we're going to get a reading off of the ion source from the device on the left using the air ion counter. And then we're going to look at the ions being generated by the two pen-like devices that you see on the right. On the left-hand side, we see a wand, zero-point energy wand that is a knockoff wand that was purchased on the internet for a fraction of the cost of the original Amega wand here on the right. Now the Amega wand, as you notice, is a little bit different than the knockoff wand, and we've shown in a separate presentation on this website that the Amega wand weighs 1.8 ounces and the knockoff wand here weighs 1.5 ounces. We found another wand being sold on the internet that weighs 1.3 ounces. So there is a difference in the weight of the wand, the Amega wand being consistently heavier than the knockoff wand, and the knockoff wand's being a little bit different in design. You'll notice that the clip doesn't touch the body of the pen as it does over here, and that the milling here on the original wand, the Amega wand, is different from the smaller milling on the knockoff wand. So again, this wand a little sharper toward the end of it, the Amega wand a little blunter, significantly heavier to the touch, and different in its operation. Now, the reason for this demonstration simply is that there are sites on the internet which show this knockoff wand next to an ion tester, and we believe that scientifically a device, solid device such as this, should not produce ions unless it is radioactive. So we wanted to subject both wands to the air ion tester to determine, number one, if they are radioactive, because then there would be a concern, and number two, do they actually produce ions, because apparently in this one particular article on the internet, it is showing the production of ions to apparently validate that the wand is doing something, and we want to test that. So we're going to go ahead and proceed with our demonstration. Okay, so in this first demonstration, I'm going to turn on the air ion counter, and we're showing right now that that the reading is relatively low, 0.00 to 0.05, and as I pull it closer to the ion generator below us here, we will see a significant increase in the amount of ions being produced. And right now it's about 17 or 18, and sometimes right off the scale. Okay, now pen number one is the knockoff pen, which was shown to have significant ion generation capabilities. And you can see as I get this close to the device, you're not seeing anything more than simple background ion generation, about 0 to 0.2. And as I bring the pen away and to the device again, you don't see any generation of ions. Now let's use the original Amega pen, which we also assert does not generate ions. If it did, it would be radioactive. And you can see here that it bounces around from 0 to 0.1 or 0.2. And so there is no ability of either the knockoff or the original pen to generate ions. So we've concluded advertisements such as this one that we've seen on the internet with the knockoff pens being pictured next to an ion tester, such as this one, with a significant reading of ions, are actually fraudulent packaging, because none of these devices, either the real or the artificial, generate ions, nor should they do so.